Hey guys, good morning. Am I audible to you? Can you please confirm the chat? Good morning. What is VIC? Arun? Voice is clear. Wow. Hey, new shortcut in IT or what? No, voice is clear. Sometimes in IT, what happens? They will implement a new words. The VIC. I will use that word then. Tomorrow class is there? That's Saturday, right? Oh, Saturday. As usual, no. Why no? Hmm. Why itna thumbs up? Tomorrow class is there, man. Is a natural Saturday, right? Natural Saturday only, that is. Whose birthday? Whose birthday? Chicken birthday. Tomorrow class is there, ma. What about Monday? What you will do with holidays? Tell me. What you will do in holidays? Want to be homesick? What you will do in holidays? Tell me. Going home, okay. Next, sleeping, eating, sleeping. Huh? Mutton biryani, chicken biryani, fish prawns. Eating and sleeping. Okay. Practice. So, which cinema is it? Dankia or Salar? Salar is it? Huh? Dankia. I am going two movies. Both movies I am going. So tomorrow's class is there. So who is booking tickets for Salar in our class? The book for all, no, 100 members. Huh? శ్రావణి will book. శ్రావణి బుక్ కరదో. బుక్ చేయమ్మా, అందరికి బుక్ చేయి. అమ్మాయిలందరూ నువ్వు చేయి, అబ్బాయిలందరూ నువ్వు చేయి. ఇంకా అందరూ వెళ్ళండి సినిమాకి, రిఫ్రెష్ చేయండి. But online people, how can they go? Online people. Huh? बोलो. Huh? Free tickets. Free tickets. Oh, free tickets, normal theater, na? I will not go to normal theaters. I will go to only malls. స్క్రీన్ మంచిగా ఉండదమ్మా, చూడబుద్ది కాదు ఆ స్క్రీన్. నాకు చిన్నప్పటి నుంచి టీవీ అంటే బాగా ఇష్టం. నాకు చిన్నప్పుడు నేను టీవీ చూడడానికి వేరే వాళ్ళ ఇంట్లో ఉంటే తప్పేనా అంటే మా డాడీ కలర్ టీవీ కొనుక్కొచ్చిండు. 90s లో కలర్ టీవీ. ఐ లైక్ టు వాచ్ మూవీ సో మచ్ ఇన్ మై చైల్డ్హుడ్. I think in 1996, I think 1997. I went to some Parso home and they given some mirchi bhaji. I slept there. My father and my mother were so much worried. Morning they have such a lot places. Finally, I came to home. They realized that, oh, this guy is passionate about TV. Then my father bought color TV. In 90s color TV. Then from there onwards, I want to see only quality pictures only. That's why I will not download these piracy movies also. I will buy. I have all the apps. All the apps I have, but I will never download this iBoma, piracy, movie rules. I never download that. Everything is coming, no nowadays. One day I went to GVK Mall to watch my movie. That movie screen is not coming. I went to complain in middle to that owner directly. I paid this much money. Then why you are doing? You come and check here like that. That is very bad. If screen is good, that is. I bought 2 lakh rupee TV. Everyone is got shocked because I like TV. I watch movies. That is big screen quality. That is. That's why I given that Salar movie ticket. That is the Arjun theater in Kukatpalli. It's a normal theater, no? I booked the tickets in GVK Mall. GVK Mall. That is Salar. And PVR Panjagutta, I booked the tickets for Donkey. So 2 movies done. Yesterday, Animal movie done. 3 movies done. Chalo. We'll start now. Sampling theorem. So this statistics part 2. Statistics part 2. What we'll cover in statistics part 2 is types of sampling, point estimates, interval estimates, central limit theorem, hypothesis testing, Z test, T test, F test, chi-square test, confidence intervals, ANOVA. Please note down these topics, ma. These are very, very important topics. All are interview kind of topics. You'll get some breathing space to practice and prepare assignments. So no breathing for next 4 months. So types of samples. So generally we works only on samples, right? Instead of population. instead of population. Correct? Everyone knows that, right? Why? Tell me. Because of time complexity. Yeah, because of time, because of money, and because of human resource. Human resource. So because of time, because of money, because of human resource, generally we'll work only on samples instead of population. So that's why when we find mean on samples and we estimate the mean value on population, and this is called, we call inferential statistics. Inferential statistics. So that's why generally we do which type of statistics? Inferential statistics. What is inferential statistics meaning? We'll work on samples and we'll estimate on the population. We'll work on samples and we'll estimate the population. We'll work on samples and we'll estimate the population. So you need to select the samples. Right? So if I ask you to go and survey the which political party will come into the in Telangana, means you will not go randomly, right? You'll also go in the some policy, procedures and all this you'll follow. Suppose I given a number of 100 people, 1, 2, 3, 4, 5, 6, 7, 8, and so on, 100 people. In that, I ask you to pick 10 members. How you will pick? In what ways you can pick? Tell me the first way. Randomly 10. Okay, second way. Every fourth person. Every fourth person. Or 100 is there, every 10th person. Every 10th person. That means first person, next 11th person, next 21st, next 31st, like that, right? Every 10th person. Here randomly, blindly you are picking of 10 members. Both are correct only? Yeah, any other options? Okay, based on gender. Based on income. Gender, or based on gender, or based on income, or based on age, whatever it is. Next, based on gender, based on income, based on age, based on area, So many things you are saying. Wow, that is. So randomly you are picking that 10 members. Every 10th person you want to picking, or based on gender, based on income, based on age, based on area, you want to pick. Anything is correct. So randomly you are picking 10 members means type is called random sampling. What is the type is called? Random sampling. Type is called random sampling. Every 10th person you are providing means it is called systematic random sampling. Systematic random sampling. Systematic random sampling. And based on gender, based on income, based on age, you are dividing, you are clustering. That means it is nothing but cluster sampling. All answers you are saying. See, random sampling you said, systematic sampling you said, cluster sampling only you said, and all the answers you only given. And everything is one name is there. Because we are human beings, we can think. And based on area. Based on area means this is called geographical. Geographical. You know, geography. Geography. Not giraffe. Geography. There's no social subject. It is called strata. Stratified. Stratified. Stratified sampling. And based on geography, so American people, one American people, you are one Indian people, one African people, one Europe people. We are picking the people based on the area, based on the geographical things. That is called stratified. Stratified sampling. So there are 4 types of samples are available now. What are that? Random, systematic, cluster, and stratified. Okay? So that all 4 you only told, not me. Correct. First you tell I will pick randomly. Next you will pick, you said every 10th member. Third you will say that I will divide into groups. In that also one division you said area. But area they provided that one another name. That is called what? Stratified. Very great. Now put citing point estimates. Point estimates. Point estimate. So we are finding mean on samples. Mean on samples. Mean on what? Sample. And this is nothing but a just a called point estimate. We are finding a mean on sample. It is nothing but a point estimate. And based on sample mean, will find population mean. Based on sample mean, we'll try to find population mean, and this population mean is called parameter estimation. Parameter estimates. So this is point estimate and this is parameter estimate. Point estimate versus parameter estimate. Point estimate versus parameter estimate. Simple. Point means single value will as output. Single value is the output. That is the point estimate. Whatever we are finding a mean and sample, it is nothing but a point estimate based on the sample mean. What your end goal? What your end goal? You want to find the population mean. That is your end goal, right? You are everything that is. Let me complete. Okay. So you are going and you are doing some survey on Hyderabad. Then based on Hyderabad result, you want to update all metro cities. All metro cities. Or based on you are in Telangana state, some cities you choose in some areas, and your end goal is what? Estimating on entire Telangana. Whatever you perform, whether it is a mean, whether it is a median, or whether it is a mode, or standard deviation, standard error, all statistical measurements. All statistical measurement. What you want to keep here in the bracket? You want to keep mean? You want to keep median? You want to keep mode? You want to keep standard deviation? You want to keep variance? Whatever it is. These all are what? Point estimates. What is called? Point estimate. Based on that, we are finding the population parameters. Population mean. And that is called parameter estimate. Based on that sample mean. Based on that sample mean. So again, here bracket, based on what you are finding. Mean you want to find, or median you want to do, or similarly mode you want to do, or anything, any statistical measurements, will find that same thing, will find the same thing, anything, either it is a mean, or it is a median, or it is a mode, anything that is. The general thing is what? It is called parameter estimate, and it is called point estimate. It is a mean, and it is a median, the mode, or anything that is. Easy? You need to remember the terminologies, point estimates and parameter estimate. The next, variance. Anything that is, any statistical measurement. Any statistical measurement you are finding for sample and you are estimating for population, and that statistics is called inferential statistics. What you are finding for sample is called point estimate. What you are finding for population is called parameter estimate. So three terminologies: inferential statistic, point estimate, and parameter estimate. What is inferential statistics? Tell me. What is inferential statistics? Population. Very good. What is parameter estimate? Parameter. Hmm. That is the inferential statistics. What is parameter estimate? Whatever you are finding the statistic for population, that is called parameter estimate. Now parameter means anything. Parameter means anything. It can be mean, it can be median, it can be mode, but that parameter for whose? Population. If that is mean, that median for sample, it is called what? Point estimate. It is a point estimate. Understood? Any doubts? Easy? Very good. Now see, suppose there are some observations are there. 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 And from those observations, we'll try to draw distribution plot, correct? Distribution plot. And the distribution plot might be normal distribution, might not be normal distribution, correct? The distribution plot might be normal, follow normal, or might not be normal. Might not be normal. Not everyone knows that is. There are some observations are there. And we'll try to draw distribution plot. It might be normal, might not be normal. Suppose the distribution does not follows normality. The distribution does not follows normality. Clear till now? Understood? The distribution follows normality. Then consider some samples, some sample sizes from those observations. Consider some sample sizes from those observations. For example, we have 1,000 observations. We divided those 1,000 observations into 10 parts. 10 parts. That means 10 sample size. Each part is nothing but some sample size. 10 parts is nothing but here, nothing but 10 sample sizes. 10 sample sizes. Each sample size is how many observations now? Each sample size is now 100, have 100 observations. This example clear or not? This example, everyone. We have 1000 observations. The 1000 observation we divide into 10 parts. The part we are called what? Sample size. Sample size. Each sample size has how many observations? 100 observations. Now calculate mean of those 10 parts. Calculate mean of those 10 parts. That means each part now what happened? 100 observations. You will calculate 100 points mean. So now how many means will happen? How many means? That is equal to 10 means. How many means now? 10 means. Understood now? How many means now? 10 means. Because 10 parts is there, 10 means. Now like this. So this is the entire data. This is the entire data. Now you divide into how many parts? So about 10 parts, this is one part, and this is another part, this is another part, and so on, so on. How many parts? You divide into some parts. You divide into some parts. Now this is 100 observations are there here. How many observations? 100. Here also how many observations? 100. And here also 100. Here also 100 observations. And so on. So this is S1, maybe sample size 1. And this is S2. And this is S3. And this is S4 and so on. Now you calculated mean of that. You calculated mean of that. That is nothing but S1 bar. What will come? S1 bar. Because of this, from these observations, you calculated mean. From these observations, you calculated S2 bar. Now this is nothing but S3 bar. Now these are point estimates or parameter estimates? Tell me, these are point estimates or parameter estimates? Yeah, this is SN bar, suppose. SN bar. These all are point estimates. Understood, Priyanka? These are the point estimates. Now, this is one value, right? This is one value, this is second value, this is third value, this is fourth value. Now, now draw the distribution for this. Now, draw the distribution plot. Now, 1000 observations, you already draw the distribution plot, right? Now, but now what distribution plot you are drawing? Only means. Only means. Then what happen? It will come like this. Suppose here now S1 bar plus S2 bar, S3 bar, maybe capital mu. Maybe here what will come? S1 will come. S1 bar will come. Here S2 bar will come. Like this. Maybe S3 bar will come. Maybe S4 bar will come. But these all are what? Now observations, not observation. These are what? Means now. These are means. These are means. These all are means. Generally, you draw the distribution for what? Observations. Now this time draw the distribution for means. If you take minimum 30 samples, if you take minimum how many? 30 samples. Definitely it follows normal distribution. Definitely follows. Pakka, there's no doubt. If you take how many samples minimum? 30. If you draw those 30, it follows a normal distribution. And this is called central limit theorem. Without this, no interview. Without this question, no interview. This is called what? Central limit theorem. Tell me, what is central limit theorem? Tell me this process. Explain me this process. Now tell me. Try to say. Suppose there are 1000 observations are there. I divide into minimum 30 parts. Minimum divide to take 30 means and draw the distribution those 30 means it will follows. That is called over central limit theorem. That is called central limit theorem. I will write here. Don't worry. Central limit theorem. Okay, I will write here. First of all, first point is, what is the first point? If data observations does not follow normality. If it is follow normality, okay, no. If it is not follows normality, then what you will do? Divide data into minimum 30 parts. Minimum divide into 30 parts. 30 parts nothing but 30 sample size. Then calculate mean of those 30 parts. Mean of those 30 parts. Now what happened here? Here will become S1, S2, S3 will come. The 30 samples is nothing but S1, S1 and similarly S2, S1, S2 and this I'll write here only S3 and S4 and S5 and so on S30. S30, S2, S3, S4, S5 and S30. They are good, right? That is yes. Also yes. So 30 samples are ready, ma. Then how many means now? 30 means. How many means? 30 means. S1 bar, S2 bar, S3 bar. S1 sample, say what you will get? S1 bar you will get. S1 bar. S1 bar. So S2. This will do with Python code also, don't worry. All will do with Python code and S30. Now step 4. Draw the distribution on those 30 sample means. 30 sample means. Then it will follows normal distribution. Maximum you can take anything, but minimum you can take how many? 30. You know how many parts you can take? 30 parts. Maximum you can take 500, 600 parts also. 30 minimum. Below 30 will not follows. It will not come. The distribution, normal distribution view will not come. If you take more than 30 only, it will come. The view, distribution plot, normality should come right like this. That will not come. So it can be any distribution Maybe it is a triangular, it is a rectangular, it is a rhombus, anything before. But if you do this process, it is coming as what? Normal distribution. And this is called central limit theorem. Central limit theorem. If data observation does not follow normality, that means that can be any type of distribution. Divide data into minimum 30 parts and calculate mean of those 30 parts and draw the distribution of those 30 sample means it will follows normal distribution. This is called central limit theorem. Very, very important. Minimum 30. Maximum unlimited. You can take anything. Minimum 30. Minimum 30 samples. Central limit theorem. Easy, right? No doubts in that. Very, very important. Central limit theorem. Just Google it. Central limit theorem. Central limit theorem. So this is one distribution, original. This is one distribution. This is one distribution. This is one distribution. But finally, what distribution we are making? Sample distribution is normal. Population. N is equal 10. N is equal 30 is coming. Look like what? Originally, this is. Normal hai to normal. It's okay, fine. But not normal. Maybe skewed. Maybe random. Maybe uniform. Finally, what we are getting? It is nothing but a sampling distribution of what? Means. That only now what we need to make here? Draw the distribution of sample means. The terminology what they are doing that? Sampling distribution of means. Sample distribution of means. Sampling you can sample both, you can say that. Sample distribution of means. The diagram will say, this diagram is nothing but central limit theorem. Finally, our main goal is convert into normal distribution. Why? Because mathematics developed only on the normal distribution. So in what way you want to achieve? Simple. Again, repeat, ma. Repeat what is central limit theorem. Say it. If data does not follows normality, then divide into 30 samples, calculate mean, then draw the distribution on the sample means it will follows pakka normal distribution. There is no doubt. It look like magic, but the magic will works. But the magic we will do in Python code. We'll do the same steps. We'll take observations. We'll use our Python skill. We'll divide the data. We'll calculate the mean. We'll put in a list and we'll plot the distribution. We'll check it. Don't worry. Okay. So, but this is called central limit theorem. Very, very important. Central limit theorem. Now here you see, ma. Now this is the one distribution, suppose. And this is another distribution. Time array. A random array like this. Okay. But when you do like this, it is coming like this. That is our goal, right? But here it is a mu. What is my here? Here it is observations will come. X1 will come here. This is the first observation. This is what will come? Second observation. Third observation. Original observations will come, right? Here what will come? Original observations. Suppose Xn will observations will come. Xn. But what will come here? What will come here? S1 bar will come. What will come? S1 bar will come. Here observation. Here what is that? S1 bar. Here what will come? S2 bar. Here what will come? S3 bar. And so on. Suppose Sn bar. You are taking minimum 30, but I can take 50, 100 also fine, right? That is what we are saying, that Sn bar. This is original distribution. This is original. This is original. This is original. But this is what? Sample mean. This is what? Sample mean distribution. Sample mean distribution. Sample mean distribution. Sample mean distribution. Here mu mean will be there. Here what will be there? Here what will be there? वो म्यू है ना, इधर क्या लिखना? X bar. There will be mu. Tell me, what should I write? What will write? Mu bar. What will write? Mu bar. What will write? Mu bar. Now mu equal to what? X1 plus X2 plus X3 so on Xn, right? And divided by number of observations. And mu bar equal to what happen? S1 bar plus S2 bar and so on. What will happen? Sn bar. Please note down this all. Divided by again, how many sample sizes you taken? That many sample sizes. Suppose small n. Suppose small n. The small n. That is a different concept. This is different concept. You do outliers. Outliers, if you remove outliers, it is not true that it is follows normal distribution. Correct. So that is a different concept. Outlier you remove or not remove, that we are not worrying. We are worrying only here normal distribution. Can we get the normal distribution or not? That is only we are worrying. That is only we are worrying now. Which cases? Without layers, without outliers. So if data follows, if data has outliers, Now second case is if data has not outliers. Data is not outliers, which means it follows normal distribution. That is not correct. That is not correct. It is wrong. Okay. It is wrong. The data might be rectangular distribution. The data might be square distribution, whatever it is, right? So outliers is not mean that is a normal distribution, mean that concept is wrong. Okay. Data as outliers or outliers is a different concept. Now data follows which distribution is a different concept. Which distribution is the different concept. The distribution might be anything, that is rectangular distribution or parabola distribution or triangular distribution or trapezium distribution or a parallelogram distribution, any distribution, right? Whatever it is, that's a distribution. Outliers might be there, might not be there, that we are not sure that. But finally our goal is what? That we need to convert into normal. So both are different concepts. Both are different things. Outlier is the different, distribution is the different. So this, understood this graph everyone? Now originally what is there? Originally x1, x2, x3. Original samples are x1, x2, x3, x4. That are the samples. That are the original samples. That are the original samples. x1, x2, x2 and x3 and x4 and x5 and xn. These are the original samples, xn. And originally what we called? Mean we called. Originally what we called? Originally we called it is called mean. That is the mean is nothing but mu. Is nothing but mu. So mu equal to, but unfortunately I'm not able to draw mu properly. So I'm just leaving like this. Mu equal to x1 bar plus x2 bar, x4 bar and the summation n. That you already know the formula, right? So just write the formula, that's all. Plus understand what you are writing. Plus and so on. We'll write some place here. That is equal to xn by total number of observations. By total number of observations. You come only this spot. Divided by n. We are good, right? Now, same thing can you write for sample now? For sample things? Original we divided how many sample sizes? Samples. Sample sizes equal to same thing, but this time x1, x2, x3, x4, right? That is S1 now. S1, S2, S3, S4, S30, Sn. Now this time what happened now? We call means of means. Means of means. Which means mean of sample means. Mean of sample means is a fancy term. Mean of means. Means of means. Some fancy term this is. It's called mean of sample means. That means you will draw this. Here S1 bar will come. S1 bar will come. S1 bar. Sorry, I will draw this only. S1 bar will come. We need to understand the difference between those two. That is our main intention here. Because we know the concept of central limit theorem. Now we need to understand how the original values and the new values. These are the new values, you can say that. Plus S bar 30. Something is gone. And n. And this terminology is called mu bar. What do we call here? Mu bar. Just draw the mu bar also. What ma? Small? Small n or capital anyhow number of samples only, no? That is the mu bar. Which sample? Digraphed, I will tell the story. Don't worry. Let me write this. I'm not able to write this. Now here n means what? Number of observations. Again, you will confuse. If you use the sample term, you will confuse. You will forget to use sample size term here. You will use samples you are using, that is correct, but use sample size term here then. From your mouth, what the term is coming, here also you will say number of samples, here also you will say samples only you will say. And then you finally you will got confused. Here what it is called? Parts. Data parts. Data parts, what we are calling? Sample sizes. Here what we are calling? Samples. Sample sizes you will confuse. That's why you call here observations. What do you call here? And here samples sizes, that is. Here also what is called? Number of sample sizes. Number of sample means here. Number of sample means. Number of sample means. Number of observations and number of sample means, mean of means. Compare original data and new distribution data. Original data is original observation, but new distribution what happened? There is not x1, x2, x3. Now it will become what? S1 bar, S2 bar, S3 bar. Now onwards, in the second part, okay, you are completely change your mindset. Okay, like Dhanush movies. First part is love story. Second part is all crimes. Okay. In the same way also, originally we are talking about the normal observations. Now onwards, always what are that observations now become? Sample means. Sample means is the only observations. Now, then what happened? Originally, this is we call differentiation. Now, difference from this, here what we are writing? Mu plus what we are writing? Mu plus 1 sigma we are writing, right? Now, sigma is nothing but in this concept, we are talking about standard deviation. The data vary called standard deviation. But in this concept, we'll call about standard error. What is the new terminology? Standard error. In the original part 1, what is that? Standard deviation. But now this time what happened? Standard errors. Now put side heading standard error. Standard error. Standard error. First tell me what is standard deviation definition? Standard error. How much one sample mean is deviated from mean of sample means. Mean of sample mean nothing but mu bar. That means how much one S bar deviation, one S bar deviation is deviated from mean of sample mean. That is nothing from mu bar. Mu bar. That is called standard error, SE. Standard error, SE. Standard deviation means how much one observation is deviated from mean. That is standard deviation. Now write standard deviation also. Standard deviation. That is sigma. It is nothing but sigma. Standard deviation. It will say that how much one observation, that is nothing but x, is deviated from mean. From mean, that is nothing but mu. Mean of observations, we can say that. Mean of observations. If you're talking originally, we got about standard deviation. Now onwards, what is the terminology? Standard error. Mu become mu bar, x become s1 bar, standard deviation become standard error. The terminology will change. Standard deviation, standard error, always talk about the how much is deviated. Generally, what you will do in the distance, like how much distance between Hyderabad to Bangalore? You'll say 600 kilometers, right? Here, what you are taking one sample to mean how much distance? How much? I am the sample, you are the mean. How much distance between them to us? In what is the measurement terminology? Standard deviation terminology, not kilometers here. Not kilometer. Both are same. Kilometer means what? Distance only. Standard deviation is nothing but what? Distance only. But that is the terminology is different. That is the Hyderabad to Bangalore. And here is what? Observation to mean. Observation to mean. So standard error used for means of sample means concept. Sample means concept. Standard deviation is for observation concept. So this is original observation. Original observations. And this is for sample means. Sample means. Now very, very simple. Observations becomes sample means. Mean become mean of observations. Mean of observation becomes now sample means of means. Mean of sample means. What the fancy term is called? Means of mean. Sorry, here S is not there. Mean of means. And next, standard deviation. Standard deviation become what? Standard error. Standard error. Standard deviation become what? Standard error. That is the terminology now onwards. So standard error formula is equal to sigma by root over n. Sigma by root over n. Sigma divided by root over n. That is called standard error. Sigma by root over n. Sigma by root over n. For degrees of freedom concept will come, I will tell you, but I don't want to confuse you now. Sigma by root over n. This one, yeah, note down this. Now I'll write the original formulas. Now you need to show me the number of sample means. Number of sample sizes, that is, we can say that. Number of observation, number of sample means. How many are there here? 30 is there, so what will come here? 30 will come. That's all. Number of observations, number of sample means. No confusion in this. By mean means what? Number of observations, right? Whatever you are doing the numerator, you count that and do the denominator. That is an average, right? Here you are doing n. Suppose n is equal 50. What is here will come? Here n is equal to 100. What will come here? That's it. There is no debate on that. That's a simple common sense. What you are writing, how many numerator you are writing, denominator, you do that. That's it. Next. She will create one table. In table, I will write the original formulas. You write the another formulas. Okay, mean x1, x bar, mean, standard deviation, and z score. Original. Let's see that. This is the original. Now this is nothing but sample distribution. Sample distribution. Original and sample distribution. Originally what we are saying, x1 bar, x2 bar, x3 bar. That we are taking. These are nothing but raw observations. Nothing but raw observations. And then here nothing but mu, mean will become what? Mean. This is a mean. This is nothing but a mean. There is nothing but a raw observations. Raw observations. And then standard deviation. Standard deviation. Sigma. And z score. Z score is equal to x minus mu divided by sigma. Tell me these values now. Write it. Fill the table. Fill the table. Easy question. Tomorrow is a very, very big session, mind. Okay. Important concept. the continuation of this after this today session, continuation. These two sessions are very, very important, today and tomorrow. Okay. Today and tomorrow, very, very important. Continuation sessions. And tomorrow morning, I will combine both batches. You both are in same. You are also one ahead actually. That's why yesterday I skipped for class to you. Actually, you're so ahead because of extra time. Every day more half an hour till 11:30 because of extra time. If you go this till 11:30 every day, 11:30, 12 o'clock, we can finish 1 month early. They feel bad. This one, right? New one. Sample means SN. Next one is what? Next one is what? Tell me. Mean of sample means. Next one is what? Standard error. Z score क्या है और? Tell me Z score what happened? Z score, Z score. What is X means? What is X means? S bar. S means what happened? S bar. Okay. S bar. Mu means? Mu means mu bar. Mu means mu bar. Correct, Ujma? Sigma means? Sigma by root over n. Formula. These are the new formulas. New rules. They are the new formulas. Yeah, here is that only. How many are this n? Same. N diya neither. N aata. There's no confusion in that. How many sample means are there? That n. Simple. Can you please confirm the chat? Everyone is good? Can you please confirm the chat? Understood today concept? Can you recap once? Explain me. Explain me what is central limit theorem, how it is changing. Explain me once. Tell me. Start explanation. Say it. అరే మంత్రాలు చదువుతున్నారు ఏంటి శ్రావ్య మంత్రాలు నేర్పించిన అందరికి See, these guys are doing all. What is that? Huh? Tell me, what is central limit theorem? We divided data into minimum 30 parts. Then step 1 is done. Step 2, calculate the means of all 30 parts. Then draw the distribution. Then it follows normal distribution. So now originally we are talking about raw observations. Now we are talking about the sample means. Originally we are talking about mean. Now mean of sample means. Originally it is a standard deviation. Now standard error. Good. Very good. Next. If data follows normality, it is okay, fine. Okay. Next, fourth side heading. Confidence interval. Very good. Very, very important, ma. One day, one guy come to for interview for mentor in the Naresh IT. I asked this question: what is central limit theorem? No, he said that no, they didn't teach me. Whatever I am asking, they didn't teach me. They didn't teach me. They didn't teach me. Then why you are coming to me? Nowadays, I am only taking the interviews for mentors. I am not selecting anyone. They are feeling like that. You people are not my students. That we are not selecting. Either 10,000, 8,000 only. 8 से शुरू हो जाएगा. 8 से शुरू हो जाएगा. Confidence interval. What is our main goal generally in the here? What is the main goal in the statistics? Find the mean for samples and estimate for population. That's the main goal, right? Similarly, find the median for sample and estimate for population. Similarly, anything, find any parameter, right? Find any metric, find any parameter for population and estimate, sorry, sample and estimate for the population. That's the main goal. Whatever we are achieving, all we are learning is, this is only the goal. There is no other goal in the statistics. We want to do analyze and anything on the sample and we'll get the conclusion on the population. So that is the only main goal. Now what happened? Whatever you are finding, whatever we are finding on samples is called, what the name is called? Point estimate. What the name is called? Point estimate. Whatever we are finding on sample, what we are calling is called point estimate. Now, but there is a tricky is there. What is the question here? What is the question? You are finding mean on sample and you are estimating population mean. You are estimating population mean. If both will match or not? Both will match or not, that is the question, right? That is the question. That is our goal. That is the only our goal. That is the only our question. I found Naresh IT average salary for one batch is 10 lakhs. If all the batches is 10 lakhs. Wow. That dream comes true. Okay. Think like that. In a school, that is 10 years school, 10 years old school, okay? 10 years old school. Every year, suppose 2020, 2132, 2123 is there. Now first class students is there. Every batch, every year, first class students, average sleep time, 12 hours. Okay, they'll generally sleep 12 hours. That is only the kid is good. Otherwise, he is not good. Okay. In the classroom also they will sleep. At home also they will sleep. 12 hours they sleep. Now you are estimating 2013 Walonka. What you are estimating, ma? 2013 first class student average sleep time is 12. Then can you conclude all 10 years? All 10 years. All 10 years first class students. First class students also have same 12 hours. This is nothing but a point estimate on one sample. This is nothing but what you call parameter estimate. It is a population. This kind of goals only you need to achieve, right? So that's why the question is what? You are finding a mean on sample and you are estimating a population mean. It's both are match or not? Both are match or not? Tell me, both will match or not? Both will match or not? It will never match. Both will never match. Because what happened? Now you see here. Now you see here. I divided data into three parts. I divided data into three parts. Part 1, part 2, part 3. Part 1, part 2 and part 3. So part 1 is nothing but part 1 will give what? One sample mean. That means mean it will provide some mean and that mean is equal 10. And part 2 also will provide what? One more mean. That mean equal to 12. And part 3 it calculate one more mean and that is equal to suppose 8. That is equal to 8. What you are concluding? This 10 equal to population mean or not? Population mean or not? If this equal to population mean or not? Population mean. And this equal to population mean. That is the only you want to calculate. If one is already equal, other two are not equal, no? If one is population mean 10 ho jayega, then 12 so 10 I equal ho jayega. If one is equal, other will definitely not equal. That means it is not always true. Sample mean is never not equal to population mean. The very simple example, you take one stone and you hit a fish in the river. What happen? You take one stone, hit a fish in the river. It will hit or not? For me, definitely not. Okay? For me, definitely not. But if you take a net, and put in the river, it will fall in the net or not? There's a chance is there. And that net is nothing but confidence interval. And this hitting a stone is nothing but point estimate. Okay? Small stone hitting is nothing but what? Point estimate. That is never hit. But take a big net is nothing but confidence interval. Interval means what? Widen. So that's why we are learning what? Confidence intervals. So that's why now interval estimate concept. Interval estimates. Put siding interval estimate. Point estimates never equal to population parameters. Point estimates never equal to population parameters. What does that mean? Sample mean never equal to population mean. Never equal to population mean. So sample mean is nothing but what we are calling is called point estimates. Population nothing but we are called what? Parameters, right? Parameter estimate. Parameters. No confusion right here? Sample mean is nothing but what? Point estimates. Point estimates. That one we are learning from starting onwards. Point means single value. Point estimates never equal to population mean. That is nothing but a parameter estimate. That means point estimates never equal to the population parameter. That is the conclusion. One sample mean is 8. One sample mean is 8. But population mean is 10. Population mean is what? 10. One sample mean is 12. But population mean is what? 10. Population mean is what? 10. Now how can you equal? Now you need to increase. Now 8. 8 is nothing but a single value. 8 is a single value, which means it is a point estimate. Now point estimate ko, now you need to add some interval to on point estimate, some interval. You need to add some interval. That means add 8 plus or 8 minus, some interval. Add something on the 8 plus, add something on the minus to the some minus. Suppose you made a interval based on 8, think like that. Based on 8, we made some interval. We made some interval that is called, I'm adding plus 4. I'm adding plus 4 and I'm subtracting minus 4. Then what is the interval? 4 to 12. 4 to 12, correct? And 4 to 12, 10 आ जाएगा ना आ जाएगा? 4 to 12 between. That means it is capturing 10 or not? The new interval 4, 12 capturing 10. Capturing value 10. And this concept we will use. And this concept is nothing but a interval estimates. And the new interval is called new interval based on point estimate is called interval estimate. Interval estimates. Very, very simple. When you calculate, you will get one value that is called point estimate, that never equal to population value. So what you need to next step? You need to add some intervals. You need to add some interval, and that interval nothing but what called interval estimate. Definitely the population will capture in that interval now. That's why when you hit the fish, it might be not hit, but when you put the net, it definitely fall. Okay, that I have taken, I copied from the textbook. It's called Open Intro. In Open Intro, they given that example, fish example. If you study, you will let you know. Otherwise, I will be the trainer, you will be the student only. Because I studied, I am able to teach. You are not able to study, then you are not able to pass the examination also. That's why reading the textbooks is very, very important. Reading the textbooks is very, very important. Code nahi, only examples. It is not, it is a textbook, right? It is not a coding textbook. It is a theoretical textbook. Understood now what is interval estimate? Tell me what is interval estimate? Fish and net. Tell me. Tell me that example only. At least interview will be happy, definitely. New interval? Why we are doing all this kind of drama? Tell me. Sample mean never equal to population mean. So sample mean what we are saying point. So one point is never equal to another point. So we need to capture that population mean. That's why what we are creating? Interval. What we are creating? Interval. Now next question is what? Next question is what? How will you increase the interval? That is the next question. How will you increase the interval? First question is point estimate. Second question is interval estimate. And third is what? How can you increase that interval? How can you increase that? What is the rules? What is the regulations? What is the rules and regulations. Point estimate is not equal to parameter estimate. So we'll add the interval, and that is the interval estimate concept. Now next question is what? Next question is, how can we choose the interval? How can we choose the interval? That's the next question. Now, have you remembered the concept is called, how can you know where is outlier exist? Where is outlier exist? Outlier definitely exists Q3 plus and Q1 minus, and you need to travel some distance. You need to travel some distance, and the distance is based on what? IQR, correct? Here also you need to travel some distance based on what? IQR. And here also I need to create an interval. That interval definitely point estimate plus and point estimate minus. Definitely, yes or no? Point estimate plus point estimate minus. But how much distance I need to travel? Now tell me, distance Bangalore to Hyderabad, distance in kilometers. But in distribution, what is the distance? Tell me. Bangalore to Hyderabad, we will measure in terms of kilometers. In the distribution, standard deviation. But now this is the Dhanush second interval. After interval, standard. Then you need to add what? Standard error. You need to add what? Standard error. But how much standard error you want to add? 1.5 or 2.5 or 3.5, 1 or 2 or 3, like that. Understood? Then the formula is nothing but K into same story. K into definitely we know point estimate plus. But how much distance you need to travel? Standard error distance. How much distance? Standard error. And then that is 1 time or 2 time or 3 times. 1 time or 2 time or 3 times. So the formula will be definitely point estimate plus or minus K into standard error. Point estimate plus or minus K into standard error. Point estimate K into standard error. This is the formula. Easy, na? So we need to create the interval. Now what is the interval become now? Point estimate minus standard error to what the interval become now? Point estimate have you link up anything on this in your first part with this? Anything? Very good. My boy. Great. Point estimate to mu plus or minus 1 sigma, mu plus or minus 2 sigma, mu plus or minus 3 sigma. What is that concept? Tell me. 68%, 95%, either 90%, 95%, 99%. Either concept. The concept shuru 90% say. 90%, 95 and 99. 90% को value क्या होना इधर k equal to 68% को 1.64, no? What is 68%? 1. 90%? 2. Now the concept is same is equal to same 90% this time. What we are writing? Empirical rule. I will just write the here, okay? Empirical rule and that. ER concept. Empirical rule concept. 68, 95, 95 and 99. And here we call confidence intervals, CI, confidence intervals, 90, 95, 99. 90, 95, 99. The 90 equal to for 90 for 90% confidence interval equal to point estimate into 1.64. Similarly, (95) is equal to 1.96. 99 equal to 2.58. 2.58. These are new values. 90% means 1.64. That means 90% confident that population mean can capture in this interval. 90% you can confident. 95% I can confident the point estimate can capture to between 1.96 to 1.96. Similarly, 99% confident that population mean can capture between this range. This range minus 2.58 to 2.58. These are the new values. Confidence interval values. Confidence interval values. Empirical rule. Empirical rule and confidence interval. For 90, 68, that one, and 1, 2, 3. Write it now here. Empirical rule concept. ER. Empirical rule. Empirical rule. Confidence intervals. Confidence intervals. 68, 95, 99. Here 90. 90, 95, 99. Mu plus or minus 1 sigma. Kada? That is 1, 2, 3. Standard deviation आता है इधर. Standard deviation. Standard deviation. Here mean point not mu, right? Here mu, population mu. 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 This we already checked with Python code, right? Mu. Your point estimate. This is also now follows normal distribution, and this also definitely follows what? Normal distribution, because we are working on sample distributions, right? That's why. 1.64, 1.96, and 2.58. So today class is very, very important, ma. So how we progress the class that understood? First we take an raw observation, then we find the central limit theorem, then we learn the point estimates, point estimates are not equal to population. Then we'll learn about interval estimate. Then interval estimate, we need to get some intervals. And this is the intervals that is called confidence intervals. 90% confident, 95% confident, 99% confident. And tomorrow class is very, very important. That is, we will work on the jet table. We'll work on the jet table. I will upload today in the Google Classroom. Please download that. And tomorrow we'll work in the class. How to understand the tables, jet table. Because tomorrow you want to construct 80%. How can you construct 80%? By using jet table, we need to check the values. Not chance. What is that? Correct. Here, what is the concept? Why you are doing point estimates? Why you are doing interval estimate? What is the concept here? To find the population mean. It is a 90% confident. 90% confident. The population mean will fall in between these intervals. What the concept is different here. I'm just comparing, but this confidence is what? To find the mean. This concept is to capture the mean. To capture the mean. But this concept is what? It is how much percentage of data available. Percentage of data capture. Percentage of data capture. There is to capture the mean, and this is percentage of data capture. Both are different. Both are different. Our main goal is point estimate is what? Mean. Estimate is nothing but anything you find, it is mean. It might be mean, it might be median, it might be mode. But what is our goal? Whether we are capturing the population mean or not. We are not capturing. So what we are doing? We are constructing a interval. Interval is what is the interval? Point estimate plus. Definitely we need to travel some distance. Distance is nothing but who here? Standard error. But how much distance? 1.64 times you travel, that means 90% confident. 1.96 you travel, that is 95% confident. 2.58 is you go do 99% confident. That we will see tomorrow. This is very, very important concept today. Statistics part 2 is very, very important always. Because statistics part 1 now you are perfect. You know the EDA, how to do and all these things, right? But part 2 will leads to machine learning concepts. So that's why part 2 is very, very important. Okay? Yeah. Thank you. Thank you so much. Sorry. సూర్య అంటే సిరి వస్తుంది అయిపోయిందా ఇచ్చిందా ఏమన్నా
వేరే వాళ్ళు లోన్ అమౌంట్ తక్కువ ఎందుకు జీరో వచ్చిందని కూడా ఆలోచించాలి. అప్పుడు ఆ రిలేషన్ బట్టి ఎక్కడ వాటిని వేరే వాళ్ళతో చేయాలి. అదే కేర్ తీసుకుంటాం వేరే వాళ్ళ మీద డిపెండ్ చేయాలి. మనం బ్యాంక్ తీసుకోవాలి సరే ఎవ్రీ వన్ ఇయర్ వేరే రావచ్చు వేరే అదొకటి పంపిణీ ఇప్పుడు అప్లికేట్ ఇన్కమ్ ఎవరైతే 5,000 ఎక్కువ ఉన్నారో వాళ్ళు 1 ఉన్నారు సార్, ఎవరైతే 5,000 ఉన్నారో అలాంటి రీసెంట్ వస్తే అలా రాస్తారు. 2 కాంబినేషన్ ప్లస్ డిపెండ్ అయ్యి ఇంకా లోన్ అకౌంట్ చేస్తే నువ్వు ఏమన్నా ఫైనాన్స్ టర్మ్స్ ఉంటాయి లోన్ వాల్యూ డిపెండెంట్ వాడుతున్నారు. అలాంటి ఫైనాన్స్ నాలెడ్జ్ వస్తే మిగతా కాలంలో మ్యాచ్ చేసుకుంటూ డిపెండ్ చేసి వస్తాయి. మల్టీమీడియా అనాలిసిస్ చేయాలి కదా, ఎందుకు లోన్ స్టేటస్ తెలుసా, ఎందుకు లోన్ స్టేటస్ నో అయినంత చెప్పాలి. ఇక్కడ అనాలిసిస్ చేయి, నువ్వు మెషిన్ లోన్ స్టేటస్ నాకు వాయిదా ఎంత మంది వస్తుంది, ఎందుకు వస్తుంది వాయిదా 2 ఆన్సర్స్ చెప్తాను. అంటే ఇస్తాను ఇప్పుడు ఎడ్యుకేషన్ లో మీకు ఫస్ట్ లోన్ అకౌంట్ సపరేట్ అవుతుంది. ఆ ఎస్ లో అకౌంట్ గ్రాడ్యుయేట్స్ నువ్వు గ్రాడ్యుయేట్ అయినా మీరు లోన్ ఇవ్వలేదు, వేరే డిపెండ్ నువ్వు ఎంప్లాయ్ కాదా, ఎంప్లాయ్ అవునా, అలాంటి ఒక 5 ఇంట్రెస్ట్ చెప్పగలరు. ఇవన్నీ ప్యాటర్న్ క్యాలిక్యులేట్ చేసి మ్యాథమెటిక్స్ డెవలప్ చేస్తుంది. మనం మైండ్ వరకు ఏం చేస్తున్నాం, ఇలాంటి అనాలిసిస్ చేస్తున్నాం, కానీ ఆ మ్యాథ్స్ మన మైండ్ లో క్యాలిక్యులేట్ చేయలేదు, ఎందుకంటే మిషన్ వాడతాం. ఆ మిషన్ మెషిన్ లేదు, ఆ మిషన్ వాడతాం. ఇప్పుడు ఎందుకు ఇచ్చినా ఎలా ఇచ్చినా ప్యాటర్న్ ఇచ్చినా చాలా ప్యాటర్న్స్ వస్తాయి. ఆ ప్యాటర్న్స్ అన్నిటి కలిపి ఒక మ్యాథ్ డెవలప్ చేయాలి, అదే మిషన్ లెర్నింగ్. ఇలా కూడా చేసేది అదే, కాకపోతే మనకు అడ్వాన్స్ చేస్తుంది మనం ఏ అనాలిసిస్ చేయగలం. అందుకే దీన్ని అనాలిస్తామా మిషన్ లెర్నింగ్ మోడల్ డెవలప్ చేసి డేటా ఈ మెథడ్ కాకుండా వేరే దాంట్లో గూగుల్ లో లైట్ బ్లాక్ అంతా బ్లాక్ పైన డాట్స్ అన్నీ ఎక్కువ very good exercise. తర్వాత అవి ఉంటాయి కానీ నువ్వు వ్యాల్యూ చూసుకోవాలి. ఇక్కడ ఈ 300 400 100 వేరే పైన అదే వైర్ ఉండదు
పైన అదే ఆ వాల్యూ వేరే అదే వాల్యూస్
ఆ
కంపేర్
డాట్స్ ఉంటూనే ఉంటాయి
ఆ డాట్స్ అంటే నాకు ల్యాప్టాప్ అడిగితే ఏంటంటే అది బాక్స్ ప్లాట్ ఉంటుంది Q3 Q1 ఈ లైన్ వరకు మన యూబి ఈ లైన్ వరకు ఎల్బి అని చెప్పి మళ్ళీ ఈ రెండింటి పైన నేను దాని తర్వాత డిఫరెంట్ రీప్లేస్ చేస్తున్నాను దాని తర్వాత డాట్స్ రావట్లేదు దాని తర్వాత కూడా డాట్
నీకు వాల్యూస్ వస్తున్నాయి
వాల్యూస్ చెక్ చేయాలి
వాల్యూస్ రావు
మనం ఇచ్చిన వాల్యూస్ బాక్స్ ప్లాట్ వస్తుంది కదా
మంచి వాటికి వస్తాయి కానీ బాక్స్ స్లాట్ మీకు ఎంత చూసేసినా కూడా ఏదో ఒక డాట్ కనిపిస్తూనే ఉంటుంది
అదే సేమ్ నాకు ఇలానే వస్తుంది ఇక్కడ కొన్ని డాట్స్ ఇలానే అదే ఈ బాగుంది అని కలిగి
స్లాట్ లో ఎన్ని చేసినా కూడా ఇంకేదో
మనకి
మళ్ళీ దీని మీద Q3 Q1 పెట్టినాం అనుకో
అది
మళ్ళీ అది కాన్సెప్ట్ వస్తుంది లోయర్ బాండ్ అప్పర్ బాండ్
మళ్ళీ
మళ్ళీ ఇంకా చేంజ్ అవుతాం
రన్ చేసిన ప్రతిసారి
చేంజ్ అయితేనే ఉంటుంది ఎందుకంటే నువ్వు కటాఫ్ ఇస్తున్నావు కదా దీనిలో కటాఫ్ రాదు ఇంకో కటాఫ్ అట్లా చేయాలి అది వేస్తేనే కనిపోతుంది డేటా అనేది కంప్రెస్ అయిపోతుంది అందుకే నువ్వు ఎంత చేసినా కూడా ఏదో ఒక కటాఫ్ తీసుకొని ఇస్తూనే ఉంటుంది
ఇక్కడ వరకు వదిలేసుకోవాలి సరిగా
నువ్వు ఫ్రీ పెట్టేసి కావాలంటే ఫ్రీ పెట్టేసి ఉంటుంది ఈవెన్ ఇప్పుడు సపోజ్ మనం చూపించాం 100 నుంచి 20 మెంబర్స్ అనాలిసిస్ ఇచ్చాం ఇప్పుడు నేను 20 మెంబర్స్ అనాలిసిస్ చేస్తే ఆ 20 వాల్యూస్ కూడా అదే కదా వాల్యూస్ కాబట్టి అది ఎప్పుడు వర్కౌట్ కాదు బాక్స్ లో ఎప్పుడు ఉంటూనే ఉంటాయి ఏ వాల్యూస్
మళ్ళీ ఏం చేసి రావచ్చు
అన్ని ఒకటే వాల్యూస్ కింద కేంద్రీకృతమైన సేమ్ కాన్సెప్ట్ ఒకటే కదా
ప్రతిసారి రీడ్ చేసిన ప్రతిసారి దాదాపు సపరేట్ అకౌంట్
పెద్దగా అయిపోతుంది Some plots are yes yes
subplots
subplots in some are plots and subplots matplotlib one c1 అనేది ఏది బెస్ట్ పిక్ చేసుకోవాలి దానికి వేరే స్పెసిఫిక్ వేరే పిక్ అయితే తీసుకోవాలి ఒకే కూడా తీసుకోవచ్చు స్లాట్ ని కూడా చూసుకోవచ్చు
plots